In this video, we'll find inverse functions and then we will compose them and do a couple extra things with them. So let's take a look at the first example. We want to find the inverse function of this linear function f of x equals 4x plus 2. The first step is to make it simple and label f of x as y. So I'm just going to do that in white here. So we'll do y equals 4x plus 2. Keep it easy. All right, the next thing that we're going to do is swap x and y. That's what inverse means. So swap x and y. So instead of y equals, it's going to be x equals. And instead of 4x, it's going to be 4y plus 2. Then the last thing that we got to do is solve for our new y. So we'll solve for y, we'll subtract 2 from both sides. So we'll have x minus 2 equals 4y, and then divide everything by 4. So we'll have y equals, and I'm just going to write it over here instead, 1/4 x minus 1/2. Now, instead of writing y, the way that we want to write this notation, since we started with f of x, this is the inverse, and the way that we write the inverse is f inverse, that looks like this, f negative 1 of x. That's how we write the inverse, f to the negative 1 of x. That is just inverse notation. Okay, in this next example, we'll have the function f of x equals x minus 3 over 7. So our first step is to just label f of x as y to keep it simple. And then our second step in yellow will be to swap x and y. So we'll rewrite it as x equals y minus 3 all over 7. Because an inverse is really just inverting x and y. They switch places. All right, now we need to solve for y. The way that we're going to do that is we'll multiply both sides by 7 to get rid of the denominator. So we'll be left with 7x equals y minus 3. And then we'll add 3 to both sides. So we'll have 7x minus 3, plus 3, sorry. We'll add 3 to both sides equals y. And that's our inverse. Now we want to write it as in correct inverse notation. We started with f of x, so we will end with f inverse of x instead of y equals 7x plus 3. The last thing we'll take a look at in this video is the relationship between a function and its inverse. If, for instance, we wanted to find something like this, f of f inverse of 2. Remember, this is composing two functions, and what this really means is that we're taking f of f inverse of 2. Now, what is f inverse of 2? That just means we're plugging 2 into the f inverse function. So I'm going to plug 2 into here. So we'll have 7 times 2, 14, plus 3. So that's 17. So f inverse of 2 is 17. Just plugged it into the function. So I replaced f inverse of 2 with what it equals, 17. And now we can find f of 17. F of 17 means plugging 17 into the f function. So we'll have 17 minus 3, which is 14, over 7. 14 over 7 is 2. So look at that. When we compose a function and its inverse, we're kind of like doing something, but then undoing it. They're inverted. It's like inverting something twice, swapping x and y twice. You're back to where you started. So if you were to input 2, you kind of go through this process and you get back to 2. Any ideas on what f inverse of f of negative 5 would be? You could go through the whole process, or based on what we just said, we're swapping twice, we output that same input, negative 5.